All right, so this is example 7, right? So we're in Eureka. We're doing Eureka math, right? Module 4, grade 6. We're on example 7. We already ran through examples 1 through 6. This is the last example from this section. So you made it. If you watched all the videos, you made it. All right. So now we're on example 7. So we have 3 responsibilities. All right. First thing we're going to do is we're going to write an expression to show C, which is a variable. C is a variable, right? Notice it's a letter. It's not a number. C minus the sum of A and B. All right, so let's first break this. Let's analyze this statement and identify the important and key elements in it. So first we're going to show C minus. C minus the sum of A and B. C minus the sum of A and B. All right, so now we got C comes first because we're not doing C less than. If we was doing C less than, then it would be the sum of A and B minus C. But this does not say less than, this says minus. So we think of minus as like a verb, right? It's an action. It's telling you what to do. It's telling you to subtract. It's representing subtraction. That's what the minus word means, all right? So we got C minus, right? C minus. That's what that is. It's like if somebody get a grade, C minus, like a 70, right? 70 to, what's like 70 to 73 is a C minus? Anyway, so C minus the sum of A and B. Sum of means the results you get when you add 2 things together. Now, when I do sum of, I always use parentheses, right? Well, 9 times out of 10, sometimes I might forget or my mind might be in another place. But most of the time, typically I use parentheses when I see the sum of, when I see the difference of, the difference between, the product of, I use parentheses, right? So I'm going to put these in parentheses, the sum of A and B. And how do I know it's plus? Because it says the sum. Sum means addition. So what we're doing here is, I want you to understand this, and I said this in some of the other videos. This is like language translation. This is like you studying a foreign language. We're going from the English language to math language. English language to math language. So this is just like if you're sitting in Spanish class, or you was in Arabic class, or you was in Kiswahili class, right? You know, you studying Yoruba or whatever the language is, and your job is to translate from English, a sentence in English into that language, whether you're going from English to Yoruba, whether you're going from English to Kiswahili or whatever, right? That's what we're doing here. So if you could do that, right, you can think of that, use the same mentality and the same approach to think of mathematics in this situation. So we got C minus, that's C minus, the sum of A and B, sum of A and B, right? Sum of meaning you add them together. You add them together, that's the sum of, right? Now, why did I put them in parentheses? Because that's how I organize my work. But in this case, in example 6, we didn't have to use parentheses. But in this case, we have to use parentheses. Because if I don't, and this is the second question, why are parentheses needed here? Because if I don't use parentheses, check this out. Then it would just say this, right? It would say C minus A plus B. That's very different. Because in the first expression that I wrote, the correct one, this means that I'm subtracting the sum of these 2 numbers. This means I'm just subtracting A. And then whatever that difference is, I'm just adding it to B. So in this setup, in the second setup, I'm not adding A plus B first and then subtracting that sum from C. I'm not doing that. I'm actually going to, in this setup, I am adding A and B first because I'm following the order of operations, which says PEMDAS or PEDMAS, right? Because you don't always multiply before you divide. That's another thing we're going to talk about, right? I got videos on this channel on that. And make sure you subscribe to the channel too, by the way, right? I got plenty of videos on order of operations. You do not always multiply before you divide. I know you might have learned PEMDAS in school and the M comes before D in PEMDAS, but you also could say PEDMAS. That's why I said that, because we work from left to right, right? When we're reading the problem. And if we see division first, you don't skip over the division and jump to the multiplication. You don't do that. That will make your answer wrong, right? So we do whatever comes first according to, right? We do multiplication or division according to what comes first. But before that, we work out all of the mathematics that's found inside the grouping symbols or the parentheses or the brackets or the braces or whatever grouping symbol it is. So in this case, you would do A plus B. Now, you could only do it if you knew values for A and B. But this is only like theoretical. It's only like a representation, right? So this is why you got to use parentheses, because you'll get a different answer, right? Because here, again, I'm going to say it again. In the first example, you find the sum of these two numbers first, if they were numbers, if you knew what the numbers were, right? Of course, you can't do it here. But you will find the sum of these two numbers first and then subtract that from this number, right? That's going to be different from if you just move from the left, subtract A from C, and then add B to that. That's going to give you a different answer, right? So that's why you got to be careful. That's why you have to use parentheses, all right? So we did this one. We did this one. Now, the last example kind of deals with what we just talked about. It says replace the variables with numbers to see if C minus the quantity, call it a quantity. Whenever the expression is inside parentheses, we call that a quantity. To see if C minus the quantity of A plus B is the same as C minus A plus B. All right, now let's see. So what they suggest, Eureka suggests, is to say A equals 1, B equals 2, C equals 3. Where'd they get these numbers from? They're arbitrary. They just picked them randomly. They load numbers in the number system, 1, 2, and 3. They're easy to work with. So that's what we're going to work with, right? So let's first do C minus the quantity A plus B. So we're going to evaluate. This is called evaluating an expression, right? When we replace letters with numbers. That's what we're about to do. So we're going to do C minus the quantity A plus B. That's going to look like this. Excuse my handwriting. It's a little sloppy, but it's cool. C minus the quantity A plus B, right? So I replaced the C with a 3. Because I said A equals 1, B equals 2, C equals 3. I replaced the C with a 3. Then I put my minus sign. Then I put the parentheses. Then I replaced the A with a 1. Then I put a plus sign. Then I replaced the B with a 2. So now, follow order of operations. I do 1 plus 2 first. That gives me 3. Then I got 3 minus 3. 3 minus 3 is 0. So, using these three numbers, using this expression, I get 0. Now, the way I could prove that these two are not equivalent expressions is because when I plug the numbers in to this expression, which is the same as this, right, I'm going to get a different number. That's how you know if expressions are equivalent. If you could plug numbers in and end up with the same number, then that means that those expressions are the same. But if you get a different number, as long as you did the math correctly, that means your expressions are different because they have different values. So let's look. We got C minus A plus B. All right, now C was still 3, A is still 1, and B is still 2. Now the order of operations tells us to work from left to right. So we don't do 1 plus 2 first. We don't do that. Well, we don't do negative 1 plus 2 first. There's no parentheses. So we go straight left to right. Now, here's another thing. Order of operations says we do addition, even though it's PEMDAS that everybody learned, right? And the A comes before the S, right? You do whatever comes first. But see, it's different with addition and subtraction. I'm going to tell you why. But typically, you do whatever comes first when you're moving from left to right. But I will tell you this. With addition and subtraction, the order doesn't matter. Because look, if I do 3 minus 1, I get 2. And then 2 plus 2 is 4. So we already know that these are different expressions because our numbers are different. But let me pivot a little bit and talk a little bit about order of operations. Notice how I just did. I just did 3 minus 1 and I got 2. 2 plus 2 is 4. But watch, I get the same thing. Negative 1 plus 2, right, is 1. Negative, let's say I do addition. Let's say I skip over the subtraction. I jump to the addition. This is not a 1, though. This is a negative 1 because that minus sign makes this a negative 1. Be very careful. This minus sign makes this a negative 1. It should be treated like a negative 1. So negative 1 plus 2 gives me positive 1. So then I got a positive 3 and a positive 1. So what do? You add them together. 3 plus 1 is still 4. So that's proof that in the order of operations, right? And like I said, I got other videos on the channel about order of operations. But in the order of operations, in terms of addition and subtraction, it doesn't matter which one you do first, right? It doesn't matter which one you do first, as long as your numbers carry the correct signs. Because what some people do is they would do 1 plus 2 and treat the 1 like it's a positive. That's wrong. Because if you treat the 1 like it's a positive, what you've done is you basically created a whole different expression. Because that's not a positive 1. That's a negative 1. Right? So you got to treat it like a negative because there's a minus sign in front of it. So you got to treat it like it's a negative. All right? So this is just like a beginner. Like these were beginning examples on how to set up addition and subtraction expressions so that eventually we can get to setting up equations, and then we can get to solving word problems. And if you can get to if you can solve word problems, you can solve life problems. And that's what it's all about, knowing how to solve problems. Like too often we don't know how to solve problems, but we're going to get problems regardless. You're going to have problems in life. But if you're a person that doesn't know how to solve your problems, what you going to do? You just stuck with the problem. And you're going to try to like escape from the problem. You're going to try to forget about the problem. And a lot of times we end up doing unhealthy things in order to not be reminded of this problem we have. So one of my goals and my hopes is that by people learning math and understanding math, right, they'll learn problem solving skills and critical thinking ability that they can apply to everyday life. And then they'll be able to better solve at least some of their problems and life will be better. All right. So this has been Eureka grade 6, module 4, lesson 9. I just ran through 7 examples. All the videos should be found within the Eureka playlist. But check us out. We'll be back for more Eureka videos. All right. Peace.